So without further ado, we're in for a super treat with Louvere Walker-Hannon, who's a MathWorks application engineering senior team lead. So in this role, she provides technical guidance and strategic direction on the implementation of AI and data science workflows for various applications. She also manages a team of application engineers. She has won awards for her work, such as We Local 2022 Engaged Advocate Award, and she has worked in 3 different engineering roles throughout her 20+ year career while at MathWorks. She has presented and continues to engage in many data science conferences and various topics, and really is an active advocate for data science and STEM. She frequently and currently volunteers with Black Girls Code, the Society of Women Engineers, also known as SWE, and the National Society of Black Engineers, NSBE, which is hosted this weekend. She enjoys helping as many people as possible via her work and volunteerism. She holds a bachelor's degree in biomedical engineering from Boston University and a master's degree in geographic information technology with a specialization in remote sensing from Northeastern University. So really excited to have her here. MathWorks is always near and dear to my heart. I've been a MATLAB user for many years. And so I'm really excited to hear from her about how we can acquire these skills and perhaps overcome barriers to work in data science so that we can all be successful. Louvere, would you like to join us? Thank you. Yeah. So without further ado, I introduce Louvere. Thank you so much.
Thank you, Dr. Washington, and thank you to those of you who are watching this session. I'm going to start by sharing my screen, and we will continue from there. So just bear with me for a second or two. And I'm going to put this in presentation mode. I only have one screen. I'm on business travel right now, and I am here, and we are going to get started. So just to check in, I hope you can see my screen. So if you could see my screen, if you could say something in the chat or maybe have a reaction, that would be most helpful. And then I will continue. So perfect. I see at least one reaction. So I see some chats. So thank you so much to the audience for verifying you could see my screen, and let us continue. Once again, thank you so much to Dr. Washington and to all of you for being here today. It is a privilege and honor to be here for this particular seminar. So how to be successful in data science. So let's begin. So one of the biggest themes that occurs with data science is, I feel, let's level set. So what is a definition? As many of you can probably guess, there are numerous definitions that exist related to data science, but a lot of them have similar themes, a lot of overlap. But I have to admit, this particular definition that I'm seeing in front of me right now resonated with me a lot. In fact, it resonates with me so much, I'm actually going to read it out loud because I think it's one of the more comprehensive definitions of data science that I've seen in my data science travels. So data science combines math and statistics, specialized programming, advanced analytics, artificial intelligence, and machine learning with specific subject matter expertise to uncover actionable insights hidden in an organization's data. These insights can be used to guide decision-making and strategic planning. This definition is from IBM. And in terms of this definition, one of the major themes that I take away is, for everything that's here, now I think about the human being who is going to implement these tasks. So another definition that I like to think about is, okay, so what is a data scientist? So presumably it's a person that's going to do these activities, but let's see. So there are some major themes related to being a data scientist. What does that entail? So it entails at a high level, I think, 2 tasks. So data retrieval and then analysis to obtain trends and patterns at a very high level. Is this the only part of the definition? No. So a definition that I have of a data scientist is as follows. So it's an individual who obtains, processes, and analyzes data to discover trends and patterns to help with decision making. So in terms of being this data scientist, a next question could be, well, how do I become this data scientist? And I have to admit, there is no one pathway. If anyone tells you that there's one pathway, I have quite a few questions for that individual. So there are multiple pathways where you could either become a data scientist or implement data science task as a part of your role. One of the takeaways I hope that we have from this seminar is you could be doing data science task in your role, but possibly not have that title. And you know what? That's fine. And guess what? It happens quite often. So if we're trying to perform data science task, how do we get started? What could we potentially do? And that brings me to my agenda for these 3 topics I hope to highlight. So highlight education-wise, what's typically needed, what's typically identified when you see possibly job descriptions or project descriptions related to data science, specifically skills that are identified, and also some resources we can consider using. So as a starting point, let's talk about education. Education-wise, once again, there are a lot of different pathways, but from what I've seen, either personally, with colleagues, or otherwise, there seem to be a few major pathways. So what are those pathways related to gaining education on this data science skills journey? So the big question comes up for a number of people. So do you need some sort of specific program that you need to attend? I have to admit, that answer is it depends. Part of the reason why I say it depends is because you have to think about and also review that criteria from a particular organization. Some organizations may require that you have a certain type of degree, while other organizations may say, you know what, you built up this portfolio, you've demonstrated the skills, that's fine. So make certain you're in alignment with whatever organization you're interested in, understand their requirements. But generally, one of the major themes is making certain that you do the research on an organization, know what's required, maybe also understand what's recommended, and then we can make some decisions. Now, for one reason or another, some organizations may not have requirements. So the next step is, let's look at the skills associated with that role or that project that you're trying to get involved with related to data science. Now, continuing on this theme related to education, there are 2, I'm going to say, types of pathways that seem to have emerged. So one pathway is you could potentially enroll in a data science boot camp, acquire the skills, get that certification, and that could be helpful for some roles or some projects. On the other hand, you have a number of data science degree programs, and these could be undergraduate programs. I think a majority of them are more so master's degree level programs, and there could be others. Now, what's the trade-off between the 2? All of these categories. So cost-wise, a number of data science boot camps tend to be more, I'm going to say, helpful in terms of cost versus degree programs. But of course, you may find some variation. The structure could be quite different. So for your degree programs, you could have an approach where it could be in person, online entirely, or hybrid. Structure-wise for boot camps, a number of boot camps, they could also have that flexibility, but I have seen where more of the boot camps tend to be more in person, at least in the vicinity where I'm located. So I typically reside in the Boston, Massachusetts area. The time commitment. So for a degree program, we're typically thinking in probably years. How long, that can vary. So is it a 4-year degree program? Is it bridged? That could vary. For a boot camp, you're typically not looking at years. It could, for example, more so be months with a boot camp. What about duration? So duration, I tend to think of, so it's related to the time commitment overall, but for duration, I think about literally kind of your courses. So do you have, let's say, courses which last for a month and then you're going to a new course, which is a structure I've seen with some boot camps, or do you have a semester-long or a quarter-long course as a part of a degree program? The certification type, so once again, typically for boot camps, you'll find yourself getting a certificate versus for a degree program, you'll wind up with that degree. And then for skills learned, this is a pretty big distinction, I feel. So a lot of the boot camps tend to give skills that you can probably use right away related to certain roles. But for your programs, your degree programs, you may get, and it depends on the program and its structure, but you may get information where you're more so going to look at not just the practical side of data science, but also maybe some theoretical information as well. But ultimately, there is no one pathway. This just highlights at a very high level, there are typically two pathways that seem to have emerged over the past few years. And you ultimately decide which one of these pathways works best for you and your needs. Now, after getting that overview of education, what about skills? And I have to admit, for skills, there are a number of skills. So the big question may be, what skills are needed to try to implement data science task? And many. This particular list is a high-level overview. I've tried to highlight, from my personal experience, working with colleagues, talking to several customers that I work with from MathWorks and otherwise, these are generally the skills that have emerged. Now, are these the only skills? No, but they tend to be more popular in terms of most of the skills that many people have mentioned. So definitely familiarity with big data. So large amounts of data is available. We saw it in the video earlier. There were some great comments about the huge amount of data that's available to many of us. Strong communication skills. So after you do this analysis, one of the biggest themes that's going to happen is you would typically need to communicate these results to someone. So whether it's verbally or through reports, communication skills would be quite helpful. The ability to write code. In other words, the ability to program. So not saying that you have to write code that's going to be used maybe out in the field, where it's going to be streamlined code that could be placed onto a device. You more so have to probably write some code to at least start to implement some of your analysis, at least to create a machine learning model to start to see the beginnings of trends and patterns. Will you be the final person writing that code? Possibly not. Knowledge of applying machine learning and deep learning to a variety of problems. So a lot of times with data science, I feel some of the language that's been used says, oh, you're using one or the other, machine learning or deep learning. I don't think that's the case. I think that you're probably going to wind up using both in most instances if you're dealing with trying to solve a variety of problems using data science. Understanding of artificial intelligence workflows. What does that mean? So there are some general steps that are implemented as we try to use artificial intelligence, which is a big part of data science. However, when it comes to implementation, you're typically going to use either machine learning or deep learning approach, or in some cases, maybe elements of the two to help perform these steps in this artificial intelligence workflow. And I'll try to highlight what that workflow looks like a little bit later. You also have being an analytical thinker. So the ability to take a problem, try to probably divide it into smaller parts to try to come up with a solution. So these are the general skills, but let's try to dig a little bit deeper. So in terms of skills, programming languages are quite important. And there are a variety of programming languages you could technically use as a part of your data science skills. These tend to be the top 5 programming languages, at least according to one website. You're probably thinking, aren't there so many websites that highlight similar information? Yes, but I will admit some of the websites tend to highlight some programming languages more than others. This particular website, I think, gave a streamlined list that I've seen where for most of the customers I've worked with, most of the work that I've done, I have seen these programming languages used or use them myself. So Python, SQL, some people pronounce it as SQL, R, MATLAB, and SAS. Now, there are quite a few other lists, but keep in mind, anything requirements-wise, programming language-wise, look at the description of the job and or the project that you are going to work on. But these tend to be some of the more popular programming languages. There's something else too. Data science can be used everywhere, and it has been for years, and that trend continues. So I have an image of Ida B. Wells Barnett. So she's known as a journalist and suffragist. However, she's also a data scientist. Why do I say this? So she was instrumental in identifying data associated with lynchings in America at the time when she was alive. And with that data that she acquired, that data was able to be analyzed to see what are trends and patterns. And in most cases, that analysis highlighted that many of the individuals who were killed from these lynchings, they didn't typically do anything wrong. There were typically other issues that were being used to try to justify what was happening, which wasn't the case. But the reason why I bring up this example is because data science is a part of our everyday lives. And in some cases, it can wind up saving lives. So in another example, I know I've used data science, and I'm hoping to more so in the future and continue to do so, to try to think about what can we do related to Black maternal mortality? Are there different types of analysis we could perform to help try to figure out other issues before possibly giving birth, or highlight issues maybe after a pregnant person has given birth? But literally, data science is all around us. Why do I bring this up? Well, in terms of data science overall, one of the major themes that comes up more prominently today is, what about industry experience? And I have to admit, with respect to industry experience, this is going to vary in terms of expectations. So depending on the industry, there may be certain standards and practices you have to implement, as well as possibly converse with regulatory bodies. So for instance, if we're thinking about the following industries, so aerospace, automotive, biotech, and government, they may have regulatory bodies that you need to be aware of and know what their standards are, what their practices are, versus some other industries. For example, software is one example, where you may not have as many standards or practices, or those standards or practices may be more localized to a particular company, maybe a department within a company, or in some cases, possibly within a particular group. But once again, a major theme that you heard from earlier, do research and find out what are these expectations, especially as you're applying to certain roles and or working on certain projects. And then you may have seen where, for some cases at a high level, some government bodies are trying to become more involved related to, it's more so not just data science, but artificial intelligence standards and practices. Speaking of standards and practices, as well as government bodies being involved, well, there are some challenges with data science. One major theme, one major category is thinking about the algorithms themselves. So, are they automated? Could, for example, we identify which algorithm was used in the first place? And are they efficient with respect to speed? Another category related to the technical aspects of data science, are the results accurate? What accuracy measurements are we using? What is the context in terms of these results? And also, what algorithms are being used, and why did we decide to use certain algorithms? But there's some additional, very real-world problems. And one major theme related to data is, yes, we have an abundance of data, but where are we getting this data from? And who's collecting this data? And then a related theme is, as a part of data science, whether it's in a current role a future role, or otherwise, we should be very mindful of bias. Has bias crept into our data? Has bias crept into our decision-making related to selecting a particular algorithm or not? These results from our data science projects and analysis, are they discriminatory? And also, what can we do justice-wise to try to make certain we can minimize, we can reduce bias, discrimination, and other related topics related to our data science work? Because these are very real issues. One of the reasons why these are very real issues is because of the connection between data science and artificial intelligence, which we'll highlight a little bit more about this here. So can we address challenges with data science? And I have to admit, I believe the answer is yes. But how do we go about doing that? So one major theme for data science is its connection to artificial intelligence. And as we've seen, as we probably have heard, there have been a number of articles and other resources that have shown that with artificial intelligence, we need to be mindful of bias. We need to be mindful of the ethics associated with artificial intelligence and a host of other similar topics. So when addressing these challenges, I think that each of us has a role to play. How much? That's going to vary, that's going to depend. But one item that gives me hope is there's some words of wisdom from Dr. Joy Buolamwini. She is the founder of the Algorithmic Justice League. And there's a quote that I'm just going to briefly highlight here as a part of the slide. So as more people question how seemingly neutral technology has gone astray, it's becoming clear just how important it is to have broader representation in the design, development, deployment, and governance of AI. The underrepresentation of women and people of color in technology and the undersampling of these groups in the data that shapes AI has led to the creation of technology that is optimized for a small portion of the world. So one of the reasons why I highlight this quote is one of the ways that we can get involved with addressing these challenges with data science is related to representation, making certain that people of a variety of backgrounds are there as a part of all those stages that Dr. Buolamwini mentioned. So data collection, design, development, and so many other stages as well associated with data science. Now, we also have some resources. I know I just have a few minutes left. So as a part of resources, you have quite a few of them. And I have to admit, I work for MathWorks and I've used MATLAB for quite some time. I'm a big MATLAB fan. So I will highlight data science with respect to MATLAB. So just as a reminder, MATLAB stands for the Matrix Laboratory, and MATLAB is a powerful analysis tool where, as a part of doing your analysis with MATLAB, MATLAB is a high-level programming language, and you can do a host of activities such as processing your data, analyzing your data, visualizing your data, and also deploying as well. If you look at this slide, you see a series of different visualizations that people have done in conjunction with data science tasks associated with different applications, whether the data was geospatial-based, image data used for an artificial intelligence application, object recognition, or otherwise. Now, in terms of using MATLAB overall with data science, this workflow that you see here, it's not just with respect to MATLAB. This is a workflow that many people are probably using with respect to data science in general. Getting access to and exploring your data, pre-processing the data, sometimes it's known as cleaning your data, developing a predictive model, whether it's machine learning or deep learning, you're developing that model, scaling up. So actually using this content out in the field. So you may have to make certain that performance is efficient, especially if you're working with the cloud or otherwise, and then integrating with larger systems or reporting out. Now, as a part of each of these stages, you can use tools from MathWorks to help out. So for example, to access data, there are a variety of functions and apps and user interfaces to help with importing data, exploring this data, discovering trends and patterns. You also have pre-processing your data. One of the major themes of MATLAB, because it's a high-level programming language, there are a variety of pre-made functions that you can call in your code to perform this analysis, to perform this pre-processing as one example category, and to also help you visualize your results. In terms of developing models, there are a variety of functions, but something newer, you have apps, you have user interfaces that can help you interactively create machine learning models, deep learning models, and analyze them and troubleshoot. You also have scaling up. So for scaling up, how can you implement tasks in the cloud? You can implement many data science tasks in the cloud. In order to do so, there are a variety of tools from MathWorks where you can interact with quite a few platforms such as Azure and AWS and others. And you can integrate your MATLAB code with other applications. So you can call Python code within MATLAB and vice versa, and do a variety of other activities. But as a part of this integration, which is that final step, you could also package and deploy your machine learning model or your analysis overall and deploy elsewhere. It could be to some other programming language, could be to a tool, or it could be to a device that's going to run externally outside of your development environment. Now, what about resources? So there are quite a few. So in terms of resources, based on what was just highlighted, there are quite a few resources related to MATLAB or data science. So you have all these links. These links will be available right after this presentation. One of my favorites is the cheat sheets, because they have a nice overview of functions and apps you can use in the MATLAB environment for data science. There are training courses, there are self-paced free courses. These are on-ramps, they are awesome, and they can help you upskill very quickly. And you also have courses as well through Coursera that highlight using MATLAB for data science. You have resources too that can help you with job searching or trying to upskill. So this particular series of links is highlighting different job boards that are specific to a data science focus in terms of the job search. You also have information related to how do I upskill, learn about certain data science topics. Also, how do I get access to data sets to help me build up a portfolio to practice data science skills. There are organizations. The AUC Data Science Initiative is one, Women in Data Science, and the Algorithmic Justice League that can help provide more insight into a lot of these challenges related to data science and techniques, possibly overcoming them. And finally, I wanted to say thank you so much for listening to me. And in terms of my connection to data science, I've used it for years, whether in school or for work as of now. And I wanted to highlight that I have a specific emphasis with exploring data science / AI with respect to how it impacts various groups of people. And one group of people is individuals of the African diaspora. So this was my keynote speech from Black in AI in 2021. What does AI for social good mean to the African diaspora? And I have a link to the presentation I can share later. Thank you so much for your time. I hope you found this informative. Please feel free to connect through LinkedIn or email me at lwalker@mathworks.com. I will stop. I've been a little over, sorry about that.
You're perfect. Thank you. That was really informative. And thanks everybody for putting additional resources in the chat, because it's all about knowledge sharing. That's what we're here for. So that was super great, super informative. And I think our poll is about to close, and we might have had some trick questions on a poll. So what I'm going to do is just take a moment and do a poll readout, and then we'll go into Q&A. So as I'm reading out the poll, if you have questions, feel free to use the Q&A button. And so we can address your questions, either comments, ideas, anything that may come to your mind. And yes, we will share links to the presentation after we are done today. So yeah, super great plethora of resources you shared with us today. Thank you. So for the poll, so thanks everybody for participating in the poll. We have 17%, 11 out of 64 currently enrolled students. And then we have 83% graduated working professionals. That's great. Oh, I think I'm going to sneeze. And if you're a student, most of our students are graduate students with some seniors and juniors. That's great. And most of us are not a currently enrolled student, that's 77%, but lifelong learning. For gender, we have 58% female and 42% male. So we have more females today. And I gotta say, happy Natural Women's History Month today. Back in 1980, Jimmy Carter, we're in Georgia, he actually designated March 2nd through the 8th, back in 1980, as National Women's History Week. So we celebrate it now all month long. So fantastic for all the ladies in the house, the data house, that is. And where do you currently live? 59% or 38 of us are in Georgia, and then 36% are not in Georgia. And then we have some international, 3 international people. So if you'd like to put where you're coming in from today in the chat, feel free to share. I'm hailing from Atlanta, Georgia. And which is not a top 5 programming language for data science. Well, if you chose Cobra or Math, MATH lab, you are right. Actually, there were 2 right answers, trick questions. MATLAB is MATLAB, all capital letters. And as you said, matrix laboratory. Why do they call it matrix laboratory? Matrices are done in arrays, and the way MATLAB structures their data is in arrays. And over the years, they've expanded that to be more than matrices. So, but that was at least the genesis of MATLAB. And what's the primary function of a data scientist? So was it problem solve, analyze data, write code, or all of the above? Well, 80% chose all of the above. That is true, yes. So it could be a little bit of this and a little bit of that. And for me, as an applied mathematician, that's why it's so fun. And then how would you prefer to upskill your data science skill set? 86% said attend a data science boot camp. And 14% said they would prefer a degree program. So that's a really interesting result there. So, hey, we'll be having some boot camps and workshops coming out soon with the National Data Science Alliance. So stay tuned. So from that, I'm going to move on to some Q&A. If anybody has any questions, feel free to put them in the chat. And yes, we will share out the resources in an email after the presentation. Let's see if we can put them all in one place. So could you just briefly elaborate on what is this difference between machine learning and deep learning? We have all these learnings, right? Isn't it all just the same thing, or really what's the difference between these two?
Okay, so at a very high level, with machine learning versus deep learning, here are kind of 3 categories that can help with that distinction. So number 1, with machine learning, one of the major themes that you'll see is, in a lot of cases, some of the data sets, this may depend on the application, may be smaller versus what you find with deep learning. So data set size, there may be a big difference. One other characteristic is with machine learning, you'll typically find that there are statistical approaches that are used directly to help with finding these trends and patterns. So for example, those that may have seen, I can use support vector machines, you would find that under the machine learning category. Versus with deep learning, what you generally have is you're using neural networks to help with finding these trends and patterns. So that's another major difference. Third and final difference, at least as of now, is with machine learning and deep learning, one major trend is with deep learning in terms of your data, when you provide your data as is, and it's kind of raw format, and you feed this into a neural network, once you get those results of those trends and patterns, what you typically may find is you can get accuracy levels that are very high, like over 90% when you see those trends and patterns, versus with a machine learning approach, one of the major themes is you may have to do some additional steps as a part of the workflow to get to that accuracy kind of right out of the box. And another major theme too with deep learning that I like to point out is it's more of a black box solution versus machine learning. where there's a lot of details that are happening with the neural network that we may not have a lot of insight into, at least not initially. I hope that helps out.
Thank you. Oh, that's great. And then somebody put in a nutshell, deep learning, essentially neural networks, is a subset of machine learning, which includes more than neural networks.
That's correct. Yeah, I can see that.
Love it. Love it. Thanks so much.
Yes.
That's great. So here in the state of Georgia, we're seeing data science coming into the curriculum in more meaningful ways, we'll say. And we're also seeing this trend across the country, the curriculum of K-12. So someone asked, what are your suggestions for teaching data science concepts to K-12 students, specifically maybe earlier on, like grades 3 through 5? Do you have any thoughts around these?
Yes, so this is a great question. Thank you so much for the question. So one of the major themes, I think, with data science overall, regardless of the age range, is to find some sort of problem that people are interested in solving. So obviously the problem of, let's say, some of us who are in graduate school will be quite different for people in the elementary school grades. So maybe start to come up with a project that the students could work on, and that project could be something of interest to the students. So I think it's great to do some brainstorming with the students and say, hey, here are these different activities, what seems interesting? And then once you identify a problem, then you can come up with pretty much a curriculum that highlights step-by-step what they can do. So you would have them follow the data science workflow, just language-wise and also task-wise. There would be differences to map to what they could do as a part of their grade level, if that makes any sense.
That is, I like that. So you give that workflow is kind of the structure, what you can bring them through. And then there's different levels or depths of expertise, either technical or conceptual, right, that the students can then explore through. I like it. Very good. And somebody asked, what cloud forms have you used in your past experience to process large data sets? Do you like Azure, AWS? What do you like? And how important is cloud computing in processing data?
So I have more so used, nothing against Azure, but more so AWS. I think part of it is related to familiarity and comfort. So once again, you could use any of these platforms. And to Dr. Washington's point, so a huge part of data science entails working with the cloud, where you're trying to process these very large amounts of data efficiently. Another major theme too is you're also in some cases trying to make certain this data could be distributed to various locations very quickly. So for example, I recall not too long ago, I had to wear a sensor related to something health-wise, and my data was being processed and it was shared with my doctor, which I consented to. And my doctor could then share with my consent to other places. And a lot of that processing took place in the cloud in order to capture a lot of that data. So not saying it's a requirement, but increasingly a large part of most data science workflows does entail working with the cloud.
Someone says, can you share on social network analysis in regards to addressing health equity? And so they do admit that this is unashamedly tied to my proposed thesis. So any knowledge you could share looking at health equity, what's happening, where it's going, what's needed?
Yes,
Yeah.
so this is an overview, and this is a topic that's near and dear to my heart. So thank you for also having this be connected to your thesis. We need more people doing research related to these various topics, especially health equity. So one of the biggest items I would say with health equity is you would definitely probably find yourself doing a lot of research in various places. So it's not just going to be online. You may have to go into a library. You may have to go into, let's say, certain record keeping locations to find some of this information, because health equity, at least in the US, this is not a new topic, and records were taken many years ago, but where those records are located, a lot of them may not be digitized at this stage. So you may have to go physically to certain spaces, do some research, collect that information to bring it back. But in terms of sharing the social network analysis. You also have quite a few spaces that are available online that can cover certain topics related to health equity. I think one of the themes that you may find is health equity is a broad topic. You may need to definitely narrow down and be more specific. Hope that helps out. There's a seminar coming up too on that topic, it looks like. Or the
Yeah,
previous
yeah.
seminar.
So a few weeks ago, we had a seminar. It was with Alex Carlisle. He's with the Aim Ahead Project, and he talked about data analytics and health disparities. So I just put the YouTube link for that presentation in the chat. So people are more than welcome to watch that. Maybe it's a dinner and data and a movie kind of weekend, right? Yeah. So what do you see as what's going to be that next thing in data science? Like we're seeing Chat GPT come out and all the different companies trying to get something else that may be similar or better than Chat GPT. We're seeing the apprehension. So what is this next thing coming out that you could foresee that will happen or may either excite or scare us?
Yeah, it's a great question. And I've only started to think about this fairly recently because there's so many changes in a short amount of time. I think there are two major themes I'm seeing. So I'm number one, seeing more, I'm going to say citizen-based data science. What does that even mean? So there are a number of human beings who are smart, who are brilliant in their own right, but for various reasons, have not gone through a full university education or otherwise, but they have this interest in data science in general with respect to issues that may be impacting their communities. So I'm seeing more and more where you're getting various groups that are starting to spring up that focus in on more citizen data science. So they have forums, they have, sessions, whether they're in person or online, to discuss topics and try to consolidate resources or specifically look for free or low cost resources. So that's one major theme that's coming up. The other major theme too, I think we're going to see more regulation come up related to AI/data science. Right now, there's a lot of flexibility, but I see a trend, especially related to there's some regulatory bodies, for example, over in Europe who have standards, and the United States in certain sectors are coming up with standards. I think we're going to see more of that. What it looks like, I don't know, but I see that as definitely an emerging trend.
Yeah, so I'm putting in the chat right now, the Office of Science and Technology Policy, they put out a blueprint for the AI Bill of Rights. And while we artificial intelligence, data science, machine learning, we enjoy the knowledge generation, the research discoveries in these. It's having some direct impacts on human lives. So how should that be regulated? Who should regulate? And because right now it's up to the companies or the individuals or the institutions to regulate how and what these things are used. How do you see this blueprint for either a Bill of Rights or a regulatory body? How's that going to play out? That's complicated.
It does look complicated. And I have to admit, based on my own limited review of this proposed AI Bill of Rights, there's already many questions that have come up from myself and other colleagues in the AI/data science space. And I think one of the biggest trends that I've seen related to these proposed Bill of Rights and other regulations is this fully comprehensive, where we're taking into account information from a variety of individuals, and that is not necessarily the case as of this time.
It'd be interesting to see how it plays out. Can you tell us a little bit more about what are some of the teaching resources that MATLAB has with respect to data science? We have a lot of folks in the room that are they want to jump in and prefer boot camp. So, are there any MATLAB or anything you could recommend? Where do people either start or intermediate or advanced, something for everybody sort of thing?
Great question. So a starting point. So those of you who are just starting your data science journey and you want to use MATLAB, so you do have on-ramps. These are free tutorials that cover no pun intended, a wide array of topics. So 3 that come to mind related to this topic: you have a MATLAB on-ramp that focuses in on learning more about using the MATLAB programming language for analysis. There's a machine learning on-ramp, as well as a deep learning on-ramp. So I think for those of us that are trying to do more in the data science space, you want to use MATLAB, those 3 on-ramps are highly recommended. And thank you so much for sharing the links for those on-ramps, because I think those 3 on-ramps are good starting points. Those of you who are, I'm going to say, intermediate level, one of the major themes I would say is there's a data science video, and I have links to these. I'll share them a little bit later. There's a data science series from MathWorks. It's like 6 or 7 videos that highlight the data science workflow and the different tools you can use. So it does tend to assume that people have some familiarity with MATLAB, but it's definitely, I think, geared towards people who are kind of in their intermediate stages of data science and using MATLAB. Anything that's more advanced, or I'm going to say more in depth, you have a few different pathways. So there are certain training sessions that cover some additional data science related topics. So there's statistical methods with machine learning, that's a separate training session. And there are quite a few others. There are deep learning training sessions too. Another one, oh great, I just saw a comment. Yes, I'm happy you love the MATLAB on-ramps. Thank you for that shout out. That's awesome. And there are quite a few others actually. And then if you're more advanced, in addition to those training sessions, I would also say if you have, any other ideas, because there are certain projects I recommend to people, feel free to connect with me through LinkedIn, and I can give some additional suggestions related to, yes, you're using MATLAB for data science, but what are some other activities you can do? But the training sessions, I think, are a helpful continuing point for people who are more advanced. And I know sometimes you think training is just for certain levels, but these trainings tend to go towards more advanced crowd related to data science.
Nice. And I see that you also have courses on MATLAB also has courses on Coursera. So
That's correct.
Absolutely. So on that last link, I put that has the courses on Coursera. Now, so some of the folks in the audience may be advanced in data science, and they would say, wow, maybe I could contribute either curricula or research with respect to data science, one of the learnings or 2 or 3. How could they jump in and maybe be a content contributor to MATLAB?
So that is a great question. There's a few pathways that come to mind. So one pathway that comes to mind automatically is feel free to contact me. So I can help with saying, okay, let's figure out which pathway makes sense. But there's a part of the MathWorks website, I don't know if you've heard of this, it's called MATLAB Central. And it's one of my personal favorites, where there's a part of MATLAB Central where people who use MATLAB can upload resources that others can download. And it's great because there are resources related to a variety of topics, and there are a number of different apps and other tools that people have created in the data science space. So if you go to MATLAB Central, there should be a space called File Exchange, and there you can see what people have contributed already, but you can also contribute too. There's also a variety of other links off of MATLAB Central where we sometimes have different data challenges. You can also contribute to the user community by, answering questions of other MathWorks users, tool users, I should say, or posting questions too. But those are, some ways to get involved with the MATLAB/MathWorks community.
I love it. Yeah. So I just put a link to the MATLAB Central there in the chat. That looks like a really fun resource. And I echo the other person who loves the MATLAB on-ramps and having them for data science. That's really cool too. I'm learning right along with them. So that's super cool, because I know I've used MATLAB in my teaching, and students tend to like it because they can either do it in the web browser or on their computer. So yeah, it's super fun. Well, thanks so much for joining us today. I know I've really been enriched by this conversation, and don't worry, everybody. This video is on our Facebook page, so you can go there. It's there, and soon it will be on our YouTube channel, so you can subscribe to our YouTube channel. And if you missed any of our previous seminars, you can check it out on YouTube. But Louvere, thank you so much for joining us today and really providing some key nuggets and resources and ideas about how we can think about data science and how we can explore and further our pathway along the data science land. So really, thanks so much.
Thank you, Dr. Washington, for having me, and thank you for attending this session as well. I'm looking forward to connecting with people through LinkedIn.
Fantastic. And I put our LinkedIn in the chat earlier, so hopefully you grab that, but we'll send that out in the email announcement.
Oh, and one last item. I'm hiring. I have an open position on my team. So please connect with me through LinkedIn and we can talk.
What's the position, I wonder?
Oh, it's a great question. So it is so I have to admit, there's a little bit of a regional dependency, but the title is as a Senior Technical Account Manager for Boston Laboratories. What does any of that mean? So you would be an application engineer who would primarily work with customers who have laboratories in Boston. And the way that you would work with those customers is you would use your technical expertise to help with providing them with guidance in terms of using the MathWorks tools for their analysis, as well as advocate for them. You would bring feedback about the products and processes back to MathWorks, as well as you would create customized demonstrations for them, and also work with a sales team to help create strategies for how to best support these customers. So it's a great job. I have a biased opinion, but it's a nice mixture between using your technical expertise, customer advocacy, as well as, it's a very, I'm going to say, multidisciplinary role as well. So if there's any interest, please let me know.
Sounds fun. Sounds fun. And I guess in the spirit of our month here, hashtag she loves MATLAB. And I know I do, and Louvere does too. And thanks everybody for joining us today. And we'll be back in a few weeks. So have a great rest of your weekend. Thanks again.